Welcome, dear traveler, to a gentle journey across our magnificent planet Earth. As you settle into your comfortable space tonight, perhaps pulling soft blankets around you or adjusting your pillow just right, I invite you to join me on a peaceful exploration of our world's most fascinating geographical wonders. The day may have been long, filled with its various demands and responsibilities. But now is your time to rest, to let your mind wander freely across continents and oceans, mountains and valleys, while your body sinks deeper into relaxation. Take a slow, deep breath with me now, feeling your shoulders release any tension they've been carrying. As we embark on this tranquil voyage together, you'll discover 100 captivating facts about the geography of our remarkable planet, each one carefully chosen to spark gentle wonder while guiding you toward peaceful slumber. Let the rhythm of these words carry you like a calm river current, flowing steadily through landscapes both familiar and extraordinary. There's no need to remember everything you hear tonight. Simply let these geographical treasures wash over you like soft waves upon a shore, each fact a stepping stone on your path to restful sleep. Before we begin our journey, if you find comfort in these peaceful explorations, consider gently tapping the like button when you feel ready, as this helps other weary souls discover this sanctuary of calm. Perhaps you'd like to subscribe to join our growing community of peaceful dreamers who gather here each night. In the comments below, share with us where in the world you're listening from and what time graces your corner of Earth as you prepare for rest. Your gentle presence helps create a tapestry of connection across time zones and continents, reminding us all that somewhere, someone else is also seeking the same peaceful escape into knowledge and dreams. Let us begin our geographical odyssey with the vastness of our oceans, those magnificent bodies of water that cover approximately 71% of Earth's surface, creating a blue marble effect when our planet is viewed from space. The Pacific Ocean alone, that colossal expanse of azure tranquility, stretches across more than 63 million square miles, making it larger than all of Earth's land masses combined. Imagine floating peacefully above these waters, watching the gentle rise and fall of waves that have traveled thousands of miles to reach their destinations, carrying stories from distant shores in their eternal dance. Moving deeper into oceanic mysteries, we discover the Mariana Trench, Earth's deepest natural point, plunging nearly 36,000 feet below the ocean's surface in the western Pacific. If Mount Everest were placed at the bottom of this tremendous chasm, its peak would still be covered by more than a mile of water. The pressure at these depths is so intense that it equals the weight of 50 jumbo jets pressing down on a single human body, yet life still flourishes in these midnight realms, proving nature's remarkable ability to adapt and thrive in the most extreme conditions. The Atlantic Ocean, our planet's second largest ocean, grows wider by approximately 1 inch each year as tectonic plates slowly drift apart along the mid-Atlantic ridge. This underwater mountain range stretches for more than 10,000 miles, making it the longest mountain range on Earth, though most of it remains hidden beneath the waves. Picture these ancient geological forces at work, slowly but steadily, reshaping our planet's surface over millions of years. each movement as patient and deliberate as your own breathing, becoming slower and deeper as you listen. Consider now the Mediterranean Sea, that historic body of water cradled between Europe, Africa, and Asia, which was once a vast desert valley millions of years ago. About 5.5 million years past, the Atlantic Ocean broke through the Strait of Gibraltar in what scientists call the Zanclean Flood, filling the Mediterranean basin in perhaps as little as 2 years. The water rushed in with such force that it carved channels in the seafloor that we can still detect today, a testament to one of Earth's most dramatic geographical transformations. The Dead Sea, nestled between Jordan and Israel, sits at the lowest point on Earth's surface that isn't covered by ocean water, resting approximately 1,400 feet below sea level. Its waters are nearly 10 times saltier than the ocean, creating such buoyancy that visitors float effortlessly on its surface, as if held by invisible, gentle hands. This hypersaline lake has been shrinking for decades, dropping by about 3 feet each year, slowly revealing ancient landscapes that have been hidden beneath its waters for millennia. Turning our attention to the frozen realms of our planet, Antarctica holds about 90% of Earth's ice and 70% of its fresh water, locked away in ice sheets that average more than 1 mile in thickness. If all of Antarctica's ice were to melt, global sea levels would rise by approximately 200 feet, completely reshaping the coastlines we know today. Yet, this continent of extremes is also the world's largest desert, receiving less precipitation annually than the Sahara, its aridity preserved by temperatures that keep water locked in its solid, crystalline form. The Arctic Ocean, Earth's smallest and shallowest ocean, experiences a phenomenon called the polar night, where the sun doesn't rise above the horizon for months during winter. During summer, the opposite occurs with the midnight sun, creating a land of eternal daylight. These extreme light cycles influence not just the ice formations, but also the incredible adaptations of life in these regions, from the microscopic algae that bloom beneath the ice to the majestic polar bears that traverse the frozen seascape. Moving to the realm of mountains, the Himalayas continue to grow taller by approximately 1/4 of an inch each year as the Indian tectonic plate pushes northward into the Eurasian plate. This collision, which began 50 million years ago, created not just Mount Everest, but an entire range of peaks that influence weather patterns across Asia, creating the monsoons that bring life-giving rain to billions of people. The word Himalaya itself means abode of snow in Sanskrit, a fitting name for these eternal sentinels that pierce the sky. Mount Chimborazo in Ecuador, while not the tallest mountain when measured from sea level, holds a special distinction as the point on Earth's surface farthest from the planet's center. Because Earth bulges at the equator due to its rotation, Chimborazo's summit extends about 1.25 miles farther into space than Mount Everest's peak. Standing atop Chimborazo, you would be closer to the stars than anywhere else on Earth, a peaceful thought to carry with you as you drift toward sleep. The Andes, stretching along South America's western edge for more than 4,300 miles, form the world's longest continental mountain range. These mountains are home to the highest navigable lake on Earth, Lake Titicaca, which sits at 12,500 feet above sea level between Bolivia and Peru. Ancient civilizations considered this lake the birthplace of the sun, and its deep blue waters still reflect the sky with such clarity that it seems to hold pieces of heaven within its depths. Now, as we've explored 15 wonders of our world, take a moment to notice how your breathing has perhaps become more rhythmic, more peaceful. If these gentle journeys through Earth's geography bring you comfort, remember you can always return here. And a simple like helps others find their way to this peaceful space as well. In North America, the Rocky Mountains showcase a remarkable feature called the Continental Divide, an invisible line that determines whether water flows toward the Atlantic or Pacific Ocean. A single raindrop falling on one side of a mountain peak might eventually reach the Gulf of Mexico, while another drop, falling just inches away, could journey all the way to the Pacific. This delicate balance reminds us how small differences can lead to vastly different destinations, much like how each gentle breath you take leads you closer to peaceful rest. The Alps in Europe were formed when the African tectonic plate collided with the Eurasian plate, folding and lifting ancient seabeds high into the air. That's why climbers sometimes find marine fossils near alpine peaks, remnants of creatures that lived in warm seas millions of years ago. These mountains continue to rise by about 1 millimeter per year, while simultaneously being worn down by erosion, locked in an eternal dance between growth and decay. Moving to the mysterious depths beneath our feet, the Earth's crust varies dramatically in thickness, averaging about 25 miles thick on continents but only about 4 miles thick beneath the oceans. Below this crust lies the mantle, a layer of hot, slowly flowing rock that extends down about 1,800 miles. The movement of this mantle material drives the motion of tectonic plates above, creating earthquakes, volcanoes, and the slow drift of continents across geological time. The Ring of Fire, a horseshoe-shaped zone around the Pacific Ocean, contains 75% of the world's active and dormant volcanoes. This 40,000-kilometer arc of geological activity stretches from New Zealand through Indonesia, Japan, Alaska, and down the western coasts of the Americas. Despite its fearsome name, many of the world's most fertile soils are found near these volcanoes, as volcanic ash enriches the earth with minerals that nurture abundant life. Iceland sits directly atop the Mid-Atlantic Ridge, making it one of the few places on Earth where you can walk between two tectonic plates on dry land. The country grows by about 2 centimeters each year as these plates pull apart, creating new land from volcanic activity. In Thingvellir National Park, visitors can literally touch rocks from both the North American and Eurasian plates, standing at the intersection of geological forces that have been at work for millions of years. The Sahara Desert, covering about 9 million square kilometers, is roughly the same size as the United States or China. Despite our perception of it as an eternal desert, the Sahara undergoes dramatic climate shifts every 20,000 years due to changes in Earth's orbit. Archaeological evidence shows that just 6,000 years ago, The Sahara was a lush grassland with lakes, rivers, and abundant wildlife, a green paradise that supported thriving human populations. Interestingly, the Sahara Desert fertilizes the Amazon rainforest through an extraordinary atmospheric connection. Each year, winds carry approximately 27 million tons of Saharan dust across the Atlantic Ocean to South America. This dust, rich in phosphorus from ancient lakebeds, provides essential nutrients that help sustain the world's largest tropical rainforest. It's a beautiful reminder of how Earth's seemingly separate ecosystems are intimately connected, each supporting the other across vast distances. The Amazon River, flowing for approximately 6,400 kilometers, discharges more water into the Atlantic Ocean than the next 7 largest rivers combined. During the wet season, parts of the Amazon can be more than 30 miles wide, creating a moving sea of fresh water. The river's mouth is so vast that the island of Marajo, sitting within it, is roughly the size of Switzerland, yet it's merely an island within a river, not even touching the ocean proper. The Amazon basin produces about 20% of the world's oxygen through photosynthesis, though this is balanced by the oxygen consumed by decomposition and respiration within the forest itself. More remarkably, the Amazon creates its own weather patterns, with trees releasing so much water vapor that they generate clouds and rainfall, essentially making their own rain in a cycle that has sustained the forest for millions of years. The Nile River, traditionally considered the world's longest river at 6,650 kilometers, flows northward through 11 countries before reaching the Mediterranean Sea. Ancient Egyptians called it the river that flows backward because most rivers in the northern hemisphere flow southward. The Nile's predictable flooding cycle, caused by summer monsoons in the Ethiopian highlands, allowed ancient civilizations to develop sophisticated agricultural systems that supported some of humanity's earliest complex societies. Lake Baikal, in Russia, contains approximately 20% of Earth's surface fresh water, more than all the North American Great Lakes combined. At 25 million years old, it's also the world's oldest lake, and its deepest point plunges more than 1 mile below the surface. The lake is so vast and deep that it would take all the world's rivers about 1 year to fill it if it were emptied. Its crystal clear waters support unique species found nowhere else on Earth, including the Baikal seal, the world's only freshwater seal species. The Great Lakes of North America contain about 21% of the world's surface freshwater and 84% of North America's freshwater. These inland seas are so large, they create their own weather systems, including lake effect snow that can dump several feet of snow in narrow bands along their shores. If you were to stretch out the combined shorelines of all 5 Great Lakes, they would reach nearly halfway around Earth's equator. Moving beneath Earth's surface, we find vast aquifer systems that hold far more fresh water than all the world's rivers and lakes combined. The Ogallala Aquifer beneath the Great Plains of the United States contains enough water to cover the entire United States to a depth of 1.5 feet. This ancient underground reservoir, filled over millions of years, now provides water for agriculture across 8 states, though it's being depleted faster than nature can refill it. The Great Artesian Basin in Australia is the largest and deepest artesian basin in the world, covering about 22% of the Australian continent. Water in some parts of this basin is believed to be nearly 2 million years old, having fallen as rain when early humans were just beginning to evolve in Africa. This ancient water travels underground for thousands of kilometers, taking thousands of years to move from where it enters the ground to where it naturally emerges at springs. Returning to the surface, the Mississippi River drainage basin covers about 40% of the continental United States, collecting water from 31 states and 2 Canadian provinces. Every second, the Mississippi dumps approximately 600,000 cubic feet of water into the Gulf of Mexico, along with millions of tons of sediment that have created the Mississippi Delta, one of the world's largest river deltas. This sediment once built new land at a rate of 1 football field every hour, though human modifications have greatly reduced this land-building process. The Ganges River, sacred to nearly 1 billion Hindus, originates from the Gangotri Glacier in the Himalayas and flows for 2,500 kilometers through India and Bangladesh. Despite heavy pollution in many areas, the Ganges has an unusual ability to retain oxygen and support aquatic life, a phenomenon that scientists attribute to unique bacteriophages that help purify the water. The river supports about 10% of the world's population living within its basin. The Mekong River, flowing through 6 countries in Southeast Asia, experiences one of the world's most dramatic seasonal flow variations. During the monsoon season, the Tonle Sap River in Cambodia actually reverses its flow, backing up into Tonle Sap Lake and expanding it to 5 times its dry season size. This annual flood pulse supports one of the world's most productive freshwater fisheries, providing protein for millions of people. The Colorado River carved the Grand Canyon over the course of 5 to 6 million years, cutting through rock layers that tell the story of nearly 2 billion years of Earth's history. The canyon is so vast that it creates its own weather patterns, with the temperature difference between the rim and the river below sometimes exceeding 30 degrees Fahrenheit. From the south rim, on a clear day, you can see for more than 100 miles, a vista that encompasses more geological time than the human mind can truly comprehend. Moving to unique geological formations, the Giant's Causeway in Northern Ireland consists of about 40,000 interlocking basalt columns formed by volcanic activity 60 million years ago. The columns are so geometrically perfect that ancient peoples believed they must have been built by giants. Most are hexagonal, though some have 4, 5, 7, or 8 sides, created by the precise way lava cooled and contracted, following the same mathematical principles that create honeycomb patterns and mud cracks. Uluru, also known as Ayers Rock, in Australia's Red Centre, is often described as the world's largest monolith, though it's actually the exposed tip of a massive underground rock formation that extends for miles beneath the surface. The rock appears to change colour throughout the day, glowing particularly red at sunrise and sunset due to the iron oxide in its sandstone composition. Indigenous Australians have considered this site sacred for tens of thousands of years, believing it was formed during the Dreamtime, when ancestral spirits shaped the land. The Cave of Crystals in Mexico contains some of the largest natural crystals ever discovered, with selenite crystals reaching lengths of 36 feet and weighing up to 55 tons. The cave maintained the perfect conditions for crystal growth for about 500,000 years, with temperatures around 136 degrees Fahrenheit and 99% humidity. The crystals grew so slowly, adding only the thickness of a human hair every century, demonstrating nature's incredible patience in creating beauty. In Vietnam, Son Dung Cave is so enormous that it contains its own jungle and river system. The main passage is more than 5 miles long, with sections reaching 600 feet high and 500 feet wide, large enough to fly a Boeing 747 through comfortably. The cave even has its own climate system, with clouds forming near the ceiling when temperature and humidity conditions are right. Discovered by local farmers but only fully explored in 2009, it reminds us that Earth still holds magnificent secrets waiting to be discovered. The Atacama Desert in Chile is the driest non-polar desert on Earth, with some weather stations never recording any rainfall. The soil in parts of the Atacama is so similar to Martian soil that NASA uses it to test instruments for Mars missions. Yet even in this seemingly lifeless landscape, when rare rains do occur, the desert can burst into bloom with millions of flowers in a phenomenon called Desierto Florido, showing that life finds ways to persist in even the harshest conditions. Death Valley in California holds the record for the highest reliably recorded air temperature on Earth at 134 degrees Fahrenheit, measured in July 1913. Despite its forbidding name and extreme conditions, Death Valley supports over 1,000 plant species, 300 bird species, and numerous mammals and reptiles. The valley also contains Badwater Basin, the lowest point in North America at 282 feet below sea level, where ancient seas once existed, leaving behind vast salt flats that stretch to the horizon. The Danakil Depression in Ethiopia is one of the hottest, lowest, and driest places on Earth, sitting at more than 400 feet below sea level. The landscape seems almost alien, with sulfur springs glowing yellow and green, salt formations creating white crystalline fields, and active lava lakes bubbling in volcanic craters. Despite temperatures regularly exceeding 125 degrees Fahrenheit, the Afar people have lived in this region for centuries, harvesting salt from ancient deposits and adapting to one of Earth's most challenging environments. Siberia contains about 10% of Earth's land surface and 77% of Russia's territory, yet it's home to only 25% of Russia's population due to its harsh climate. The region experiences the greatest temperature variation on Earth, with some areas seeing temperature differences of more than 190 degrees Fahrenheit between summer highs and winter lows. In the town of Oymyakon, considered the coldest permanently inhabited place on Earth, the average January temperature is negative 58 degrees Fahrenheit, so cold that people leave their cars running all day to prevent the engines from freezing solid. The Greenland ice sheet, covering about 80% of Greenland's surface, contains enough ice to raise global sea levels by 24 feet if it completely melted. This massive frozen reservoir is up to 2 miles thick in some places and has existed for at least 18 million years. Scientists drilling ice cores from Greenland can read Earth's climate history going back over 100,000 years, with each layer of ice containing tiny bubbles of ancient atmosphere, perfectly preserved time capsules of our planet's past. Moving to geological phenomena, geysers are rare features found in only a few places on Earth where specific geological conditions align perfectly. Yellowstone National Park contains about half of the world's geysers, including Old Faithful, which erupts approximately every 90 minutes. These natural fountains require three things: an abundant water supply, an intense heat source, and a specific underground plumbing system that allows water to become superheated before explosively converting to steam. The word geyser itself comes from the Icelandic geyser, meaning to gush, named after a specific geyser in Iceland that has been active for 10,000 years. The Great Rift Valley, stretching from Lebanon to Mozambique, is slowly splitting the African continent in two. In about 10 million years, East Africa may break away from the rest of the continent, creating a new ocean basin. The valley is already dotted with lakes, many of which are highly alkaline and support unique ecosystems. Lake Natron in Tanzania, for instance, is so caustic that it can preserve animals that die in its waters, creating haunting calcified sculptures that seem frozen in time. New Zealand sits at the boundary of the Pacific and Indo-Australian tectonic plates, making it one of the most geologically active countries on Earth. The country experiences about 20,000 earthquakes each year, though only about 200 are strong enough to be felt. This geological activity has created a landscape of stunning variety, from fjords carved by glaciers to active volcanoes, geothermal fields, and mountains that rise directly from the sea. The entire country is essentially a geological museum displaying millions of years of Earth's sculptural artistry. Japan consists of nearly 7,000 islands, though only about 400 are inhabited. The country sits at the junction of four tectonic plates, resulting in frequent earthquakes and volcanic activity. Japan experiences about 1,500 earthquakes each year that are strong enough to be felt, and it has 10% of the world's active volcanoes. This geological instability has profoundly influenced Japanese culture, architecture, and philosophy, creating a deep appreciation for the transient nature of existence. Indonesia is the world's largest archipelago nation, comprising more than 17,000 islands, stretching over 5,000 kilometers from east to west. The country has more active volcanoes than any other, with 127 currently active. The 1883 eruption of Krakatoa was heard 3,000 miles away, and its ash clouds lowered global temperatures by more than 1 degree Celsius for a year. Today, Anak Krakatoa, meaning child of Krakatoa, continues to grow from the sea where its parent volcano once stood. The Philippines consists of 7,641 islands at high tide, though this number decreases at low tide when some smaller islands become connected. The archipelago formed through complex tectonic processes over millions of years, creating one of the world's most biodiverse regions. The Philippines sits within both the Ring of Fire and the Typhoon Belt, experiencing about 20 typhoons each year, making it one of the most disaster-prone countries, while simultaneously being one of the most resilient. Madagascar, the world's fourth largest island, separated from Africa 165 million years ago, allowing its plants and animals to evolve in isolation. About 90% of Madagascar's species are found nowhere else on Earth, making it one of the world's biodiversity hotspots. The island is sometimes called the eighth continent due to its unique ecological and geological characteristics. Its central highlands were formed by volcanic activity, while its coasts showcase ancient coral reefs lifted above sea level by tectonic forces. Australia is the only country that is also a continent and is the flattest and driest inhabited continent on Earth. The continent has been so geologically stable for so long that it lacks recently formed mountain ranges, and its soils are among the oldest and most nutrient-poor in the world. This geological antiquity has contributed to the evolution of unique flora and fauna found nowhere else, with about 85% of flowering plants, 84% of mammals, and 45% of birds being endemic to Australia. The Indian subcontinent is moving northward at about 2 inches per year, the same speed at which human fingernails grow. This movement began about 70 million years ago when India broke away from the supercontinent Gondwana and began its journey across the Tethys Ocean. The collision with Asia that began 50 million years ago not only created the Himalayas, but also dramatically altered global climate patterns, potentially triggering ice ages through changes in atmospheric circulation and rock weathering patterns. Europe and North America are moving apart at roughly the same rate, about 1 inch per year, as new oceanic crust forms at the mid-Atlantic ridge. If this rate continues, in about 200 million years, the Atlantic Ocean will be wider than the Pacific is today. This slow continental drift means that New York and London are about 6 feet farther apart than they were when the Mayflower sailed in 1620, a poetic reminder of how our planet constantly reshapes itself, even as we sleep peacefully through the night. The Scandinavian peninsula is still rising from the weight of ice sheets that melted 10,000 years ago, a process called post-glacial rebound. Parts of Sweden and Finland are rising by up to 1 centimeter per year, gradually increasing their land area. GPS measurements show that the land in the northern Gulf of Bothnia will rise another 300 feet over the next 10,000 years. This slow rise has been recorded in human history, with Viking Age harbours now sitting far inland from the current coastline. Examining Earth's climate zones, the Antarctic circumpolar current is the world's largest ocean current, moving 130 million cubic meters of water per second, more than 100 times the flow of all the world's rivers combined. This massive flow of water completely circles Antarctica, effectively isolating it from warmer ocean waters and helping maintain its ice sheets. The current has been flowing for about 34 million years, since the opening of the Drake Passage between South America and Antarctica. The Gulf Stream transports more water than all the world's rivers combined, moving warm water from the Caribbean to northwestern Europe. Without this oceanic conveyor belt, countries like the United Kingdom and Norway would have climates similar to Alaska, despite being at the same latitude. The Gulf Stream moves at about 4 miles per hour at its fastest, carrying enough heat energy to keep northern Europe habitable and supporting ecosystems that wouldn't otherwise exist at such high latitudes. The Intertropical Convergence Zone, where trade winds from both hemispheres meet near the equator, creates a band of clouds and storms that circles the entire planet. Sailors call this region the doldrums because the winds can be calm and unpredictable. This zone shifts north and south with the seasons, bringing monsoons to different regions and essentially controlling the rainfall patterns for billions of people living in tropical regions. From space, it appears as a belt of bright white clouds wrapped around Earth's middle like a celestial equator. The jet streams, rivers of fast-moving air flowing west to east at altitudes of about 6 to 9 miles, can reach speeds exceeding 200 miles per hour. These atmospheric highways influence weather patterns across entire continents and can cut hours off intercontinental flight times when planes ride along with them. The position and strength of jet streams determine where storms will form and travel, making them crucial factors in weather prediction and climate patterns. The trade winds, named because they aided sailing ships carrying trade goods, blow consistently from east to west in tropical regions. These winds are so reliable that ancient Polynesian navigators used them to explore and settle islands across the vast Pacific Ocean, navigating thousands of miles of open water using only the stars, currents, and these dependable winds. The trade winds also drive ocean currents that influence global climate and support some of the world's most productive fishing grounds. Earth's magnetic field, generated by the movement of liquid iron in the outer core, extends thousands of miles into space, protecting our planet from harmful solar radiation. This invisible shield deflects charged particles from the sun, preventing them from stripping away our atmosphere. Without this magnetic field, Earth might look more like Mars, which lost most of its atmosphere after its magnetic field weakened billions of years ago. The magnetic poles wander over time and have reversed many times throughout Earth's history, with the last reversal occurring about 780,000 years ago. The aurora borealis and aurora australis, the northern and southern lights, occur when charged particles from the sun interact with Earth's magnetic field and atmosphere. These dancing lights typically appear in oval zones around the magnetic poles, creating curtains of green, red, blue, and violet light that shimmer across the night sky. Indigenous peoples have watched these lights for thousands of years, creating stories about spirits dancing in the heavens, while modern observers still find them equally magical and mysterious. Looking at unique geographical features, the Salar de Uyuni in Bolivia becomes the world's largest mirror during the rainy season when a thin layer of water covers the salt flat. This 12,000 square kilometer expanse is so perfectly flat that it's used to calibrate satellite altimeters. The salt flat contains about 10 billion tons of salt and holds 70% of the world's lithium reserves. When dry, the salt forms hexagonal patterns similar to those at the Giant's Causeway, showing how nature repeats its geometric preferences across different materials and scales. The Eye of the Sahara, also known as the Richet structure, is a mysterious circular feature in Mauritania that's visible from space. This 40-kilometer wide formation was once thought to be an impact crater, but is now believed to be a deeply eroded geological dome. The concentric rings of different rock types create a bullseye pattern that has served as a landmark for astronauts and appears almost like Earth winking at the cosmos. Some have romantically suggested it could be the location of the legendary Atlantis, though geologists favor more prosaic explanations. The Door to Hell in Turkmenistan is a natural gas crater that has been burning continuously since 1971, when Soviet engineers accidentally created it while drilling. The crater measures about 70 meters wide and 20 meters deep, glowing with orange flames that never extinguish. Local spiders are attracted to the warmth and have created silk webs around the edges, somehow surviving in this infernal environment. The crater has become an unlikely tourist attraction, a reminder of humanity's sometimes dramatic interactions with Earth's geological resources. Mount Roraima, a tabletop mountain or tepui on the border of Venezuela, Brazil, and Guyana, inspired Arthur Conan Doyle's The Lost World. Its summit is an isolated ecosystem that has been separated from the surrounding lowlands for millions of years, supporting unique species found nowhere else. The mountain creates its own weather, almost perpetually shrouded in clouds, with rain falling nearly every day. The summit is a labyrinth of stone formations, crystal valleys, and pools that seem to belong to another planet entirely. The Chocolate Hills of the Philippines consist of more than 1,700 cone-shaped hills spread over 50 square kilometers. During the dry season, the grass covering these limestone hills turns brown, giving them their chocolate-like appearance. Local legend says they were formed from the tears of a giant, though geologists explain them as weathered marine limestone uplifted from the seafloor. Their remarkable uniformity in shape remains something of a geological mystery, as if Earth decided to practice its geometry skills. The Zhangjiajie National Forest Park in China features thousands of quartzite sandstone pillars, some rising over 200 meters high. These pillars formed over millions of years through physical erosion and expanding ice in winter. The area inspired the floating mountains in the movie Avatar, and often appears wrapped in mist, creating an ethereal landscape that seems to float between earth and sky. Ancient Chinese paintings depicting impossible mountain scenes were likely inspired by this very real but surreal landscape. The Blood Falls in Antarctica flows from the Taylor Glacier, staining the ice red with iron oxide. The water comes from a subglacial lake that has been isolated for about 2 million years, containing ancient microbes that survive without oxygen or sunlight. The water is 3 times saltier than seawater and never freezes despite emerging at -5 degrees Celsius. This crimson cascade against pristine white ice creates one of Earth's most striking color contrasts, like the planet itself is painting abstract art. Pamukkale in Turkey, meaning cotton castle, features terraced pools of mineral-rich thermal waters that have created white travertine terraces over thousands of years. The ancient Romans built the spa city of Hierapolis around these natural hot springs, believing in their healing properties. The calcium carbonate deposits create pools that look like frozen waterfalls or clouds materialized into stone, each pool reflecting the sky in shades of turquoise that shift with the light throughout the day. The Fly Geyser in Nevada was accidentally created in 1964 when a geothermal energy company drilled a well that was abandoned. Mineral deposits have built up colorful mounds around the continuously spouting water, with thermophilic algae adding brilliant reds and greens. The geyser continues to grow, adding several inches each year, creating an ever-evolving sculpture that demonstrates how human actions can inadvertently create new geological features that nature then claims as its own. Looking at Earth's extremes, the Challenger, deep in the Mariana Trench, is the deepest known point in Earth's oceans, reaching down approximately 36,000 feet. The pressure at this depth is more than 1,000 times greater than at sea level, equivalent to having 50 jumbo jets stacked on top of a person. Only 3 people have ever reached the bottom in person, fewer than have walked on the moon, making it one of the last true frontiers on our planet. Mount Thor on Baffin Island in Canada has the world's greatest vertical drop at 4,100 feet, with the cliff overhanging at an angle of 105 degrees in some places, meaning it actually leans outward beyond vertical. This granite cliff face presents one of the most challenging climbs on Earth, taking skilled climbers several days to ascend. From the top, the drop is so sheer that a stone thrown from the summit wouldn't touch the cliff face until it hit the ground. The Veryovkina Cave in Georgia is the deepest known cave on Earth, extending down 7,257 feet. Exploring this cave takes professional cavers several days of rappelling, climbing, and navigating through water-filled passages. At its deepest point, the weight of the rock above creates a palpable sense of the Earth's mass pressing down. The cave continues to be explored, with new passages discovered regularly, reminding us that even in our mapped and measured world, mysteries still await in the darkness below. Lake Vostok in Antarctica lies beneath 2.5 miles of ice and has been isolated from the rest of the world for at least 15 million years. This subglacial lake is about the size of Lake Ontario and may contain unique life forms that have evolved in complete isolation. The water remains liquid due to geothermal heat from below and pressure from the ice above. Scientists drilling toward the lake must be extremely careful not to contaminate this pristine time capsule that might hold clues to life's ability to survive in extreme conditions. The Bentley Subglacial Trench in Antarctica is the lowest point on Earth, not covered by ocean water, reaching 8,300 feet below sea level, though it's filled with ice rather than exposed land. If all the ice were removed, seawater would rush in to create a deep bay. This hidden depression is deeper than the Grand Canyon and was only discovered through ice-penetrating radar, showing how much of our planet remains hidden from direct observation. The McMurdo Dry Valleys in Antarctica are the driest places on Earth, with some areas receiving no precipitation for millions of years. The valleys are kept dry by katabatic winds that can reach speeds of 200 miles per hour, evaporating any moisture. Despite the extreme conditions, life persists in the form of bacteria living inside rocks, protected from the harsh environment. These valleys are considered the closest terrestrial equivalent to Mars, providing insights into how life might survive on other planets. Considering Earth's resources, the Witwatersrand Basin in South Africa has produced about 40% of all gold ever mined in human history. This ancient seabed, formed 3 billion years ago, contains gold deposits that were concentrated by ancient rivers and then buried and compressed over eons. The mines here extend more than 2 miles underground, where rock temperatures exceed 140 degrees Fahrenheit, and the pressure is so great that without support, the tunnels would collapse within minutes. The Permian Basin in Texas and New Mexico contains one of the world's largest oil and gas deposits, formed from an ancient sea that existed 250 to 300 million years ago. Marine organisms died and accumulated on the sea floor, eventually being buried and transformed by heat and pressure into hydrocarbons. This basin has produced oil for over a century and continues to yield new reserves through advanced extraction techniques, powering much of modern civilization from the remnants of prehistoric life. The Democratic Republic of Congo contains about 70% of the world's cobalt, a crucial component in batteries for electric vehicles and electronic devices. This mineral wealth lies in the Katanga Copper Belt, formed by ancient sedimentary processes that concentrated metals in layers. The geology that created these deposits involved multiple cycles of erosion, deposition, and metamorphism over hundreds of millions of years, creating one of Earth's most concentrated deposits of critical minerals. Moving to population geography, more than half of the world's population lives within 60 miles of a coastline, despite coastal areas representing only about 10% of Earth's land surface. This concentration reflects humanity's historical dependence on the ocean for food, trade, and transportation. Rising sea levels threaten these coastal populations, with some estimates suggesting that 600 million people live in areas that could be affected by coastal flooding by the end of this century. The Northern Hemisphere contains about 90% of Earth's human population, largely because it contains 68% of Earth's landmass. This asymmetry affects everything from global weather patterns to economic development. The concentration of population and industry in the Northern Hemisphere even causes a measurable wobble in Earth's rotation, demonstrating how human activity has become a geological force in its own right. Tokyo, Japan, is the world's largest metropolitan area by population, with over 37 million people living in the Greater Tokyo area. This massive concentration of humanity exists in one of the most seismically active regions on Earth, requiring extraordinary engineering to protect against earthquakes. The city has sunk by more than 4 meters over the past century due to groundwater extraction, even as skyscrapers continue to rise ever higher, creating a vertical city that expands both up and down. The Ganges River Basin supports more than 600 million people, making it one of the most densely populated river basins on Earth. This concentration of humanity in a single watershed means that the river's health directly affects more people than live in all of North America. The basin encompasses only 2.5% of Earth's land surface, but supports nearly 10% of the global population, demonstrating how certain geographical features become crucial lifelines for human civilization. The Nile River Valley and Delta contain about 95% of Egypt's population on just 3% of the country's land area. This narrow strip of green in the desert has supported continuous human habitation for over 5,000 years, making it one of the longest inhabited regions on Earth. Satellite images show this concentration dramatically, with the inhabited areas glowing bright against the dark desert, like a river of human light following the water's path. Looking at human modification of geography, the Netherlands has created about 17% of its current land area by reclaiming it from the sea through an elaborate system of dikes, pumps, and polders. This human-made geography requires constant maintenance, with thousands of kilometers of dikes holding back the sea. About 26% of the Netherlands lies below sea level, protected only by human engineering, making it one of the most dramatic examples of humanity reshaping geography to suit its needs. Dubai has created over 300 kilometers of new coastline through artificial island construction, including the famous Palm Islands visible from space. These islands were built by dredging sand from the Persian Gulf and spraying it into carefully designed shapes. The construction has altered local ocean currents and marine ecosystems, showing how modern technology allows humans to redraw maps in ways previous generations could only dream about. The Three Gorges Dam in China has created a reservoir so massive that it has measurably slowed Earth's rotation by increasing the moment of inertia. The redistribution of 39 trillion kilograms of water has lengthened the day by 0.06 microseconds. While imperceptible to humans, this demonstrates the scale at which human activities now operate, literally altering the planet's fundamental movements through space. Venice, Italy, built on 118 small islands in a lagoon, is sinking at a rate of 1 to 2 millimeters per year while sea levels rise. The city has flooded regularly throughout its history, but the frequency and severity of flooding has increased dramatically in recent decades. The MOSE project, a system of mobile flood barriers, represents humanity's attempt to preserve geography that exists at the delicate intersection of land and sea, culture and nature. The Aral Sea, once the world's fourth largest lake, has lost 90% of its volume since the 1960s due to irrigation projects diverting its feeder rivers. What was once a thriving inland sea supporting fishing communities is now mostly desert, with rusting ships sitting in sand where water once lapped. This transformation represents one of the most dramatic human-caused geographical changes in recorded history, visible from space as the blue of water gave way to the beige of exposed lakebed. As we near the end of our geographical journey, let's consider how climate change is reshaping Earth's geography. The Arctic is warming twice as fast as the global average, causing permafrost to thaw and release methane and carbon dioxide that had been locked in frozen soil for thousands of years. This thawing is causing the ground to buckle and sink, destroying buildings and infrastructure while creating new lakes and wetlands. Entire coastlines are eroding as sea ice that once protected them disappears. Greenland is losing about 280 billion tons of ice per year, enough to fill 120 million Olympic-sized swimming pools. This melting is exposing land that has been covered by ice for millions of years, revealing new islands and fjords. The weight loss is also causing Greenland to rise, a process called isostatic rebound, similar to how a mattress springs back when you get out of bed. The Sahel region of Africa shifts north and south over decades and centuries, expanding and contracting the Sahara Desert's southern boundary. This transition zone between desert and savanna supports millions of people whose lives are intimately connected to these shifts. A few inches of additional rainfall can mean the difference between harvest and famine, between staying and migrating, showing how small geographical changes can have enormous human consequences. Coral reefs, sometimes called the rainforests of the sea, are bleaching and dying as ocean temperatures rise and waters become more acidic. The Great Barrier Reef has experienced several mass bleaching events in recent years, transforming vibrant underwater cities into ghostly white graveyards. These reefs protect coastlines from storms and support about 25% of all marine species, making their loss a geographical and ecological catastrophe that will reshape both marine and terrestrial environments. Sea level rise is not uniform across the globe due to ocean currents, gravitational effects, and land subsidence. Some areas are experiencing sea level rise 3 times faster than the global average. Small island nations like Tuvalu and the Maldives face complete submersion within decades, potentially creating the first climate refugees to lose entire countries. This represents an unprecedented geographical phenomenon where nations might cease to exist not through conquest or geological catastrophe, but through gradual submersion. Mountain glaciers worldwide are retreating, exposing rock that hasn't seen sunlight for thousands of years. These glaciers are often crucial water sources for billions of people, storing water as ice during wet seasons and releasing it during dry periods. The loss of these water towers threatens water security for major rivers like the Ganges, Mekong, and Yangtze, potentially affecting more than 2 billion people who depend on glacier-fed rivers. The Amazon rainforest, often called Earth's lungs, is approaching a tipping point where it could transform from rainforest to savanna. This transformation would release massive amounts of stored carbon and fundamentally alter weather patterns across South America and beyond. Some parts of the Amazon are already releasing more carbon than they absorb, switching from carbon sink to carbon source, a change that could accelerate global climate change. Antarctica's Thwaites Glacier, nicknamed the Doomsday Glacier, is the size of Florida and holds enough ice to raise global sea levels by more than 2 feet if it completely melted. Warm ocean water is melting it from below, creating cavities that destabilize the entire glacier. Its collapse could trigger a chain reaction, destabilizing other glaciers and potentially raising sea levels by 10 feet or more overcoming centuries. As our journey through 100 geographical facts draws to a close, we're reminded that Earth is not a static stage, but a dynamic, ever-changing planet. Every mountain is either growing or eroding, every coastline advancing or retreating, every desert expanding or contracting. The ground beneath us moves, the magnetic field around us shifts, and the climate enveloping us changes. We live on a planet that breathes, with ocean currents as its circulation, the water cycle as its breath, and volcanic eruptions as its heartbeat. These 100 facts we've explored tonight are not just curiosities, but windows into the profound interconnectedness of our world. The dust from the Sahara feeds the Amazon. The mountains of Tibet influence the monsoons of India, and the ice of Antarctica affects sea levels in Miami. We are all passengers on this remarkable spacecraft Earth, traveling through the cosmos at 67,000 miles per hour, protected by a magnetic field and a thin layer of atmosphere from the harsh vacuum of space. As you drift towards sleep tonight, perhaps you'll dream of floating above the Mariana Trench or standing atop Mount Chimborazo, closer to the stars than anywhere else on Earth. Maybe you'll imagine the slow dance of continents across geological time, or the patient growth of crystals in dark caves. These wonders exist whether we observe them or not, continuing their ancient processes while we sleep, while we dream, while we live our brief moments on this extraordinary planet. Thank you for joining me on this peaceful exploration of our world's geography. If these gentle wanderings through Earth's wonders have brought you comfort and calm, consider subscribing to continue these nightly journeys together. Your likes and subscriptions help other restless souls find their way to this peaceful corner of the internet where learning and relaxation intertwine. Share in the comments below what geographical wonder you'd most like to visit in your dreams tonight. May your sleep be as deep as the ocean trenches, as peaceful as a mountain lake, and as restorative as the morning dew. Let the knowledge of Earth's wonders settle gently into your subconscious, creating landscapes of learning in your dreams. Rest well, dear traveler, knowing that you are part of this magnificent planet's story, connected to every mountain, river, and shore through the shared experience of being Earth's children. If you're still awake and yearning for more peaceful explorations, another journey awaits in our next video. Until then, sweet dreams and peaceful slumber.